Good evening, everyone. Good evening, and welcome to what promises to be an illuminating and informative panel discussion about the solar eclipse, which will take place on April 8th. I am Dr. Inga Musselman, Vice President for Academic Affairs and Provost at the University of Texas at Dallas, and I am delighted to host this event this evening. With the eclipse less than 2 weeks away, it is important to start preparing for the first total eclipse in the Dallas-Fort Worth area since 1878, and the last one here until the year 2317. That is nearly 300 years from now, so no wonder everyone is so excited about this one. I would like to introduce our panel for this event, the 2024 Solar Eclipse, Perspectives on Safety, Science, and Society. Our moderator is Tom Wong, Assistant Managing Editor for Journalism Initiatives at the Dallas Morning News. Mr. Wong edits Enterprise and Daily Stories, oversees the newsroom's internship program, and leads the newsroom's community-funded journalism initiative, which seeks philanthropic support of public service journalism. Our panelists this evening are all UTDallas faculty members who have various connections to astronomy. Dr. Philip Anderson, who earned his master's and doctoral degrees from UTDallas, now is director of the William B. Hansen Center for Space Sciences and professor of physics in the School of Natural Sciences and Mathematics. Dr. Anderson earns the prize for eclipse travel. He went all the way to Argentina to visit the 2019 total solar eclipse. Dr. Pamela Gosson is a professor of literature and of the history of science in the Harry W. Bass Jr. School of Arts, Humanities, and Technology. She teaches courses on the history of astronomy and cosmology, which include perspectives on the scientific, historical, cultural, and artistic significance of astronomical events. Dr. Gosson was quoted by UTDallas magazine as saying that witnessing an eclipse can be a humbling, personal experience that can change the way we think about our place in the universe. Dr. Mary Urquhart is a planetary scientist and department head of science and mathematics education in the School of Natural Sciences and Mathematics. She teaches astronomy and other related courses and directs the UTDallas program, which prepares science and math teachers. Dr. Urquhart's resume includes work on numerous NASA-funded projects, and she is the UTDallas representative on the Texas Space Grant Initiative. Just as April 8th will be a day to remember, I'm sure this panel will help us feel properly prepared to witness this incredible celestial event. Tom, I now invite you to begin the discussion.
Thank you, Dr. Musselman. First, a show of hands. How many of you were here for the 1878 total eclipse? We got two gentlemen over there, okay. And how many of you expect to be here for the one after this coming eclipse? 2317, all right, so you're gonna have to make sure that you're exercising a lot every day. I wanted to give sincere thanks to UTDallas for hosting this really illuminating forum, and wanted to especially say that UTDallas is an important partner because they support the Dallas Morning News' Education Lab, which is our expanded education reporting team. our Arts Access Initiative, which is our partnership with KERA in covering culture and arts through an equity lens, and most especially our science reporting. It's because of UTDallas that we've been able to work with really talented young journalists who might have a science background, and they also want to be journalists. You might recognize the byline Adithi Ramakrishnan. She's really done a lot of great science reporting in Dallas, and now we've developed her and she's on her way to Associated Press, so we're looking forward to seeing her work there. I also wanted to thank the Dallas Morning News. My boss, Amy Hollifield, is in the audience, and the Dallas Morning News is a special place that is still very much dedicated to public service journalism in a very challenging environment. And you'll be able to find all of our coverage of the total solar eclipse at dallasnews.com/eclipse. So a shameless piece of self-promotion on my part. And just a housekeeping note, one incentive for all of you to stay through this presentation is that you'll all get Eclipse glasses at the end. You know, those are pretty rare items to be found right now. So on April 8th, 2024, a total solar eclipse will sweep across North America. Most of the Dallas-Fort Worth area is in the path of totality. What that means is that we're smack dab in the middle of this path where there will be total darkness. Can you imagine that? I believe that the moon will start to block the sun around 12:23 p.m., just around lunchtime on that Monday. And then around 1:40 p.m., total darkness will fall on Dallas-Fort Worth. And it'll last for nearly 4 minutes. So we're going to have a lot of journalists out in the region covering what's going to happen across the Metroplex. But can you imagine just nighttime during the day and traffic and pets going wild, children going wild? It's going to be a really interesting time. I'm really excited about our panel. So I really feel that we've got some really wise experts in the room, people who are also extremely passionate about science and history and the total solar eclipse. So I wanted to get all of our panelists on board quickly through almost a lightning round of answers. And I wanted to pose a question. Have you all seen a total solar eclipse before? And can you describe what was the most memorable part about it? So, Phil, would you like to start us off?
So I was in Argentina in 2019. Went down there for we often have science meetings associated with the eclipse. In fact, the triennial Earth-Sun Summit is actually occurring the week here in Dallas, the week of the eclipse. So I was down in Argentina for a meeting. And I'm sure that my other panelists will say basically the same thing. It's an incredible experience, but it's kind of eerie because one of the things that you feel is the temperature drop. And the temperature can drop as much as 10 degrees. So you literally feel the temperature change. And the other thing is that the animals, the birds, the birds stop singing. And so it's a kind of an eerie feeling, honestly. Some of you probably had the chance to see the annular eclipse in October, and the same thing happened during the annular eclipse. But during the solar eclipse, when it was a total darkness, it's an eerie experience.
And Phil, can you describe, like, where were you in Argentina, and what was the environment like there?
We actually went out to the desert. There was an area out in the desert. It was just clear as a bell. Nice clear skies, relatively warm, out in rocks and true desert. So it was actually a perfect viewing spot for it.
So you had planned it all in advance and knew where you wanted to be at that time?
Well, there was a meeting. It was in San Juan, Argentina, and it was actually a science meeting down there. So it was all planned out, yes.
Okay. And Pam, what was your experience like?
Well, I've actually seen 3 eclipses, and each one was completely different. The very first one I saw was back in medieval times when I was in kindergarten. My main memory was how all the very caring and very careful adults around us, little 4- and 5-year-olds, kept saying, "Do not look at the sun," which of course, made all of us want to look at the sun. But their way of getting around it was they had given us an assignment to bring a shoebox from home that we got to decorate with planets and stars and glitter. I remember distinctly all the glitter. And then they magically turned them into pinhole cameras and then taught us how to keep the sun behind us as we viewed the crescent shape inside the box. So that was a very wise way for them to make it a fun and interesting experience for us little ones, but then also kind of save us from our impulsive selves. The second one I saw was in August of 2017, and the quilt that's up here in front is a souvenir I got from that experience. During that time, we chased the solar eclipse clear across the sandhills of north central Nebraska. The morning that we woke up in our campground, we were completely socked in with fog. There was just no way we could see for miles, and we thought, okay, this is not going to do. So we jumped in the truck and drove another 200 miles due west, hoping against hope that we would get clear of it. And with 25 minutes to spare, we broke out into pure sunshine. So that was great, but that also got the heart racing, right? And where we landed was in a beautiful state park that had a completely clear view of the open horizon because we had a lake in front of us. So you could see all the predicted phenomenon just perfectly from the moment when the light changes and you suddenly feel like you're in a live action black and white movie from back in the 30s or something. And then you start to see the shadow bands start to snake across the road. We could see this huge shadow of the moon start racing toward us. And you can literally feel the velocity of it, and then it kind of almost sweeps over you. So you feel like you're under a huge thundercloud of some kind. And then you start to see all the phenomenon of totality. Bailey's beads start to emerge. You see the diamond ring effect and all of that. And the weirdest thing was that all this was happening out in the middle, literally, of nowhere. Usually there are 2 people per square mile in this part of western Nebraska, but we were literally covering every single highway and byway and gravel road with human beings. Everywhere you looked, it was lined. And it was awesome because on this particular day, beautiful summer day, our closest neighbor in the observing line had actually flown in that night from Dublin, Ireland, just to see that experience. So it really reminded us that global events can truly bring us together, right? And then my third experience was just this past October in Roswell, New Mexico, where we saw the annular eclipse, which means there was still a ring of fire all the way around the sun. And we were in a remote wildlife refuge with a small group of very interesting folks. There were retired physics teachers and NASA engineers and wildlife photographers, and every single one of them had driven cross-country to get to New Mexico, and they'd come from New York and Boston and DC and Florida, and every single one of them had come in a different color of Subaru. Go figure. But the unexpected and really coolest part of all of that was that we were joined there by 15,000 migrating sandhill cranes, which, if you know what they sound like, they are constantly trilling to each other, making sure the whole family knows where the rest of the family is. And as soon as it started to get dark and the temperature dropped, and it got so cold that we could see our breath that morning in October, they got completely silent. It was so strange. But it also kind of reminded you that, yeah, all living things are experiencing that cosmic moment at the same time. So it was cool.
Pam, that's just an exquisite description of those 3 eclipses, and I think it's just a good reminder that we've got this opportunity here that we can't take for granted, and we almost need to make sure that we're immersed and paying attention and not like looking at our phones at that moment. And before we move to Mary, you mentioned the black and white movie, and I want to hear just a little bit more about that effect. So it's literally the colors are starting to gray out?
Yes, it's almost like a sepia tone kind of effect, at least it was in Roswell, really distinctly that way. and you start to lose sense of color, the whole color spectrum. So when you're looking across at your spouse or whoever you're observing with, you realize, gee, this looks freaky. And you also notice the distinct edges on everything that you're viewing as well. Things just seem like they're in really sharp focus. Like, it's almost like being an optometrist and they say, is this better or is this better? And it's like, no, it's all better. Yeah.
And the shadow of the moon, so why are we seeing it race?
If you're lucky enough to be facing in the correct direction as it's starting to come at you, right? I don't know, do we have the path up there? I guess we don't quite. But when we do show the map where it shows the path, there we go. If you're in its direction, like literally it will sweep past you about, I think, 1,700 miles an hour on average, something like that. So it's super fast, and it is just, you literally see it coming, just like a big thundercloud, except it's moving way faster.
Yeah, I love how UTDallas is listed there. That's the center of the universe. Mary, what was your experience?
So I saw it in 2017 in Tennessee. I was lucky enough to actually be on a friend's land out in the country, and we certainly didn't see the shadow rush toward us, and I think because of all the trees in the way. So if you're here in the DFW area with lots of trees or there are lots of buildings, you probably won't have that same experience that Pam was fortunate to see. But what I will say is we definitely saw the eerie. So the shadows become very strange. And for those of you who saw the October eclipse, we saw a bit of that as well. The quality of light changes dramatically as we move towards totality. In October, we only had 80% coverage of the sun, and it still was enough to be noticeable, and we still noticed that drop in temperature. But once we started to really move toward totality, that's when things got very strange. It was twilight all the way around the horizon. And when the moon completely covered the sun, you could look up and you could see the stars, and you could see planets, and hoping for good weather on April 8th, because we will see that, and there are multiple planets up in the sky that are going to be near the sun, and it should be absolutely amazing. But even if we have clouds, it's still going to get very dark, and the animals will still act very strangely. So we had out in the Tennessee summer cicadas singing. We won't have those, of course, in April, but it was just amazing to hear the cicadas stop and the crickets start and the dogs barking all in confusion, and then suddenly the light comes back and the crickets give up and the cicadas start again. So just imagine that environmental change. It's going on all around us. The animals are sensing it, humans sense it, and it is really a profound experience to go together. So I remember just being amazed, even though as a scientist I knew it was going to happen, at seeing the stars come out and be visible next to the corona of the sun. Just absolutely breathtaking and a profound experience for me.
Mary, you mentioned the planets might be visible. So what does that look like?
It would look like it would on a nighttime sky, right? So the nights when we have planets that are actually visible in the sky. In this case, they're going to be up during the day, so usually they wouldn't be visible to us because the sun's light, all that scattered light that turns the sky blue, that would keep us from seeing them. But in this case, we will be able to see them, again, weather permitting.
And so why don't we talk about, let's take a step back and talk about what actually causes a total solar eclipse, just to help us get some grounding on that. Mary, do you want to take that?
Sure, and why they don't happen every month. I think I can talk about that as well. So we are looking at the moon passing directly between us and the sun, and that's going to depend on a couple things, is whether or not we actually can have a total eclipse. It's going to depend on where the shadow of the moon is actually falling relative to the Earth. It's also going to depend on where on Earth that shadow is falling. So there's a total eclipse somewhere on Earth about every 18 months. Clearly, they don't happen very often at any particular location on the planet. The shadow is relatively small. And you have to be in the right phase of the moon as well. So I brought props because I teach teachers, so I have to have props. you probably can't hear me. Can you hear me?
Yeah.
Okay, so here I have 2 hula hoops. Thank you very much, Pam. This one represents the orbit of the Earth around the sun, my nice yellow hula hoop. Notice it's almost a perfect circle, something I always talk to my students about with seasons. And then I have this other hula hoop, and this other hula hoop represents the orbit of the moon around the Earth. And they are in 2 planes that are tilted with respect to each other by about 5 degrees. And so what that means is that about twice a year, the planes line up so that the shadow of the moon can actually fall on the Earth, or in case of a lunar eclipse, the shadow of the Earth could fall on the moon. And we call those eclipse seasons, and they happen roughly twice a year. Where exactly this happens does change from year to year, which is how we can get an eclipse in August in 2017 and one in October and then in April in 2023 and 2024. So having all those things line up exactly right is really important. So the phase of the moon has to be right, and then you have to be an eclipse season. And the other part is just the moon is actually quite far away from the Earth compared to what most people think. So if you think about where the International Space Station is, that's 1/1000th of the way to the moon. And so the distance between the Earth and the moon, having that right geometry in terms of the planes crossing, and then being in the right phase, all of that has to happen for an eclipse to happen somewhere on planet Earth.
Mary, and we'll go to Phil next, but you know what I struggle with a group of very skeptical journalists in my newsroom is explaining to them why this is a very rare occurrence, even though you're saying it happens every 18 months, but our ability to see it is probably more than that, I mean less than that.
So it's every 18 months somewhere on planet Earth, now mostly water, so a lot of eclipses will happen largely over the water, and just in terms of what is on our surface of our planet. The other thing that makes this special, though, we don't have to go anywhere. Phil had to go to Argentina. Pam had to go to Nebraska. I had to go to Tennessee to see eclipses before. We, here in DFW, can walk right outside of our door, and if we have a clear view of the sun, we can see the solar eclipse. Now, how convenient is that? It is absolutely amazing.
Phil, do you want to add to both the kind of the basics behind an eclipse, but then also why it is a powerful moment?
Yeah,
Why
so just a couple things. You'll notice the strip is only about 50 miles wide. So you can imagine the circumference of the Earth is 25,000 miles in circumference of the Earth. What does that mean? That means that it's just a tiny part of the Earth that strip is on. And as Mary said, 75% of the Earth is water. The other thing I wanted to mention was, we mentioned there's an annular eclipse last October. So the moon and the sun, the Earth rather, has an elliptical orbit around the sun. So when the Earth is at perigee, which means it's the closest to the sun is larger. So it's just like your hand. When I move my hand closer to the face, it fills up more of a geometrical area, where it's farther away, it's smaller, right? So when the sun is close, it's bigger. Well, the moon also has an elliptical orbit. And so when the moon is at perigee, again, it's bigger. When it's at apogee, which is farthest away, it's smaller. So during an annular eclipse, the moon is actually farther away, so it's smaller, and the sun is closer, so it's bigger, so the moon doesn't quite cover the sun. So you get what's called an annular eclipse, and you have the ring, what they call the ring of fire, because the moon doesn't completely cover the sun. And so we are fortunate that the moon is closer to perigee, so it's bigger, and the sun is closer to apogee. And so the moon completely covers the sun. And so we get a full eclipse. We get a full total solar eclipse.
And why is that such a big deal? I mean, if we...
Well, We'll talk a little bit later on about the science, but if you look at, well, we don't have it up there yet, but you see a total eclipse, you can see the corona, which is the outer layers of the sun's atmosphere. And the only time we can see it is during an eclipse. So for science purposes, and we'll talk about the science later on, it's literally, before we were able to go up and take images in space, it was the only way we were able to study the sun's atmosphere and the outer layers of the sun and take pictures of it, the corona. But that can only happen during a total solar eclipse.
Mary?
So yes, I just wanted to add to that in terms of what the apparent size of the moon. In astronomy, we call that an angular size. You've probably heard of a supermoon or a mini moon. So when we think about what a supermoon looks like, the moon will be basically that angular size in our sky, but we'll be seeing the night side of the moon, so it'll be in the new moon phase. And that is why we can have a total solar eclipse. So just to add those common phrases. And in terms of the other thing that you were saying, I'm trying to remember what I was going to talk about. Oh yes, in terms of the annular eclipse. And what the difference is. For one thing, you won't need these during totality. And you always do during an annular eclipse. The other thing too, it doesn't become as dark during an annular eclipse. So it's going to be a very different experience, even for people who saw full annularity.
And I mean, it's important to remember that the annular is not the annual eclipse. It's
Correct.
a much more rare
Correct.
event. Pam, your specialty is in history and cultures, and especially older cultures. So tell us about why this is a big moment, especially when it comes to history.
Well, I'm going to talk a little bit later about some of the, longer history, but I think actually in terms of very recent human history, this is going to be significant for a lot of folks here because obviously we are still in the fourth year now of an ongoing pandemic, and a lot of us have been feeling quite a bit more isolated and kind of actually even alone in our big city lives. And most of us here on this campus, for instance, and everywhere else that we're embedded in DFW, we are in a large metro area that's full of hardscapes. Everything around us is human-made stuff, from highways to byways to parking lots, shopping centers, et cetera. And I think a lot of us can start to feel pretty disconnected from the natural world because of that. It can start to feel like, the only way to see nature is to go 1 billion miles away to get there. Nature's somewhere really far away from us. But as Mary is saying, this time you don't need to go to a mountaintop to Argentina or to the middle of the ocean to see it. Nature, literally the whole cosmos, is going to be coming directly to us. And it's a chance for us to really feel that, even in the middle of the space that we live in.
I've also been told by friends who've experienced it that there's this incredible sense of community, I guess, with everyone seeing it together. Can you say a little bit more about that?
Yeah, I can say that definitely happened when we were at the 2017 eclipse. I think for one thing, there hadn't been one for a good long while out there in the middle of Nebraska, and for everybody to be out there in a place where they knew that usually most humans didn't gather, for one thing, mostly more cows than people as usual, but when we were all out there, after it began and everybody was quiet, all you could hear, kind of pinging all around you were everybody's little, Eclipse apps on their iPhones telling them glasses on, glasses off. You could hear them all over the state park, but after it really began, it got very, very quiet. Humans stopped the chit-chat, and they just watched. And the one thing that was so cool about it is when it started to reverse and you started to see all the phenomena in the opposite order, people just started to cry. There were people with tears streaming down their faces. They were like, did we just see that? Did that just happen? And people were hugging their kids and such. They had brought out a lot of their elders. There were folks in even wheelchairs that apparently had come straight from the assisted living because they wanted them to see this, wanted something on their bucket list, right? So you could see that this was really meaning a lot to the human family, right?
So I think one question that's probably on a lot of our minds is where can we see the eclipse in the Dallas-Fort Worth area, and what advice do you have on that?
Well, we have this chart behind us. Everything that shows it within that path of totality, Everywhere there will be able to see it. All you need to have is a clear view of the sun. So that usually will mean looking toward the southern part of the sky. You need to watch out for buildings. You need to watch out for trees being in the way. We fortunately have a lot of trees on campus, which is wonderful, but it does make it a little more challenging finding those places where we're actually going to be observing the eclipse. The good news is, again, anywhere within these lines we'll be able to see it, but some things people need to be aware of is the timing as well. So is it now the time to talk about that, or will that be later?
Well, let's also talk about, so what we're seeing here is, it's kind of zoomed out. So the bottom margin is kind of the, I guess it's the southeastern edge of the path. And
Correct.
Then it goes all the way up past Fort Worth. And then the middle line is where the maximum totality will be.
Right, so that middle line at Ennis, roughly, when the shadow is in the DFW area, that's going to be about 4 minutes, 22 seconds of totality. The closer you get to those outer edges, the shorter it's going to be. So here on the UTD campus, it's going to be about 3 minutes and 26 to 27 seconds, depending on exactly where you are on the UTD campus. So it will vary by location, and that's something that people definitely need to keep in mind.
And I'm sorry, go ahead, Phil.
Yeah, I mean, if you look Denton, if you're up in Denton, you're not going to see it.
Yeah.
So just be careful to make sure you're in that. And by the way, we are very fortunate. Another thing that we're fortunate about is that we're in a place where the maximum time for the eclipse occurs. It's actually a little bit south of here in South Texas, is where in that entire path from Mexico all the way up through to Canada, here in Texas is when you have the longest eclipse, over 4 minutes. I mean, that's actually a long eclipse. I mean, in Tennessee, the 2017, it was only 2 minutes and something.
Yeah, absolutely. Even toward the center line, it was less time than we'll have here on this campus or, say, in downtown Dallas.
And by the way, that's again that size of the moon and the size of the sun. That determines how long and where it is with respect to the plane of the orbits. But we're very fortunate. I mean, and also this eclipse goes through major population centers. I mean, you compare it to the 2017 eclipse, there are, I forget the number, I remember looking at it, it's like 100 times more people in the path of this one than there was in the 2017 eclipse, because it goes through major population centers.
Yeah, and I believe Dallas-Fort Worth is probably the largest metro area in the path. And then I think it's also important to know, and Phil, say more about it, if you're in Denton, it's not like a gradation degree of difference. I mean, it's just not going to be the same thing. Mary, you want to take
Yeah, there is no such thing as partial totality. You either have totality or you don't. Right, so we will need to make, if the people who are on the outside edge, so the western edge of Fort Worth there, or up toward Denton, they want to come to us, and in fact we have colleagues from the University of North Texas. They're going to be helping some school kids in Mesquite on the day of the eclipse with the observing, because they want to be in that path of totality.
And one other thing I wanted to say, if you want to know where to look, go out the day before and look between 12:30 and 3 o'clock. Where is the sun between 12:30 and 3 o'clock? It's going to be in the southern sky. At eclipse, it's going to be around 60 degrees in the southwest sky. But just go out and look, where's the sun between 12:30 and 3? Where is it at 1:41? If you can see it the day before, you can see it on the day of the eclipse.
Mary, go ahead.
And as far as exact timing, we have on our website, which is on your handy-dandy program, we have linked to timeanddate.com. That is a really great place to figure out what the timing is. We also have a link to the American Astronomical Society, and they have partnered on creating an app that can go on your phone. So all of that is really useful information to figuring out how to view it safely where you are.
Do any of you have any out-of-town visitors coming in, and how are you handling that? Mary, go ahead.
Well, for one thing, we will not be having a big public event here at UTD just because we don't have a football stadium, we don't have the parking. So any visitors will have to come with me in my car if they're coming to campus, use the same parking space that I'm using. And I just think it's going to be really good to have that opportunity for people to see it who aren't otherwise in the band of totality. So a lot of people, I think, are having a lot of visitors coming in.
Will all three of you be on campus, or are you staking out some other locations?
It depends on the weather.
Oh, so you're going to try to chase it then, huh?
What's that?
You're going to try to chase the eclipse locally?
Yes, I actually am going to hop in an airplane and fly where it's the
All right, well,
weather's
okay, Phil, tell us more about that. What is your plan?
Well, I actually did this for the annular eclipse. I actually, because I fly, I went down to Kerrville, and I went down and watched the annular eclipse, and it was kind of nice. You land at the airport and get out and get your camera out and took some pictures, and then hopped back in the plane and went back. But I will guarantee you, on the morning of April 8th, I will be getting on the weather charts and looking where it's clear, and if it's not clear here, my wife and I will be hopping in the plane and flying somewhere where we can. We're lucky enough that we have some partners with a plane, so that's our plan.
Mary, Pam, how about you?
Well, I'm kind of in between also. I may be on campus with my spouse with our solar filter and our telescope, or if it's cloudy, we may try to do some kind of remote, try to film it for Mary and ship it over here. So we'll see what we have to do.
Yeah, and I'm running observing things on campus, so rain or shine, I will be here, and my colleague Mark Hairston will be here, and my colleague Jim McConnell will be here, and we are each of us in charge of one of our observing sites on campus.
And by the way, if it is cloudy, you can go to the NASA site, and you can actually watch it in real time on the NASA site.
And in fact, I recommend doing that anyway, because it'll be great, but definitely don't use that for the timing of totality.
Let's segue to Pam to talk more about people in the past, because I think it's fascinating what ancient civilizations made of eclipses and how these cultures responded to them.
Yeah, so, I teach the history of science and the history of astronomy, which most people didn't even know there was such a thing. But one of the things that we talk about in class a lot is that this is something that every known culture around the whole world, that is from our earliest evidence on, has observed solar eclipses and has speculated about their causes and their meanings. And there are hundreds and thousands of different interpretations. There's not just a single cultural kind of consensus about what they mean. Because I think the sun, obviously its warmth and its light are so strongly associated with our daily cycles of life, the renewal of every new day, its life-giving properties, it makes sense that a lot of cultures would be very naturally concerned when something happens to disrupt those patterns, right? So a lot of different cultures, and these are folks that have had a long history of living in the current path of totality, all the way from the Maya in Mexico through the Choctaw and Chickasaw in Oklahoma up to the woodland people up in the northeast part of the US and up into Canada. All of those groups developed some kinds of rituals associated with their particular belief systems. So the Maya and the Choctaw and the Chickasaw, for instance, they had rituals of noise making and rattle shaking and bang potting and shouting, because their belief was they needed to try to scare away whatever it was that was covering the sun so it could be brought back again. And a lot of those stories have something to do with some kind of prey. Could be frogs, could be ravens, something like that are swallowing up the sun. But then there's also other groups in that same path of totality that tell a different kind of set of stories. And those have things to do with the fact that somebody in their group experienced some kind of physical harm or illness during an eclipse. So those tribes and family groups have developed traditions of actually avoiding being outdoors during eclipses. That's to prevent that from happening again. So for example, our near neighbors in New Mexico, the Navajo Dene people, they consider eclipses to be a very solemn and private time. This is a big struggle between life and rebirth, between the sun and the moon, and it's not necessarily something that humans should be interfering with or intruding upon. So human beings are expected to be reverent and respectful during this time. There's a big struggle going on up there in the cosmos. So the more respectful thing is to be in kind of thoughtful and private prayer and humility at that moment. And then clear up in the northeast part of the U.S., other indigenous groups actually have completely different sets of beliefs and understandings. They see the eclipse as a very positive sign of renewal and regard them as a kind of big reminder to appreciate the sun's universal gifts. They consider eclipses as a sign to recommit to living in harmony with each other as humans and also with the patterns of nature itself. So some knowledge holders associate, for instance, the solar eclipse, some of them are still arguing about it, between probably around 1142 is the consensus, as inspiring possibly one of the world's oldest democracies, established by the Haudenosaunee people. And that became literally what some of you may recognize more as the Iroquois Confederation eventually. So I often tell my students in my history and science classes and things that we discuss in there that as our abilities scientifically to predict eclipses has improved over time, now folks, I think, can still enjoy observing them as kind of mind and spirit expanding reminders that we are all born members of the Skywalker family. We, every moment that we live and walk across our home planet, we are always already spacewalking. We live on spaceship Earth, spinning on our axis, orbiting around the sun, within a solar system and a galaxy that are also hurtling through space. Once you kind of get a sense of that understanding, I think it can create within you a very strong sense of awe in the face of obviously the great unknown and potentially unknowable, but it can also create a great sense of wonder at the endless possibilities and the beauties that are still out there to be discovered by those of us who are lucky enough to be living in the universe.
It's very well put. Let me see a show of hands for those of you who are Skywalkers out there. All right, and how about Anakin Skywalkers? No one? Okay. For Mary and Phil, any other interesting facts or stories around eclipse history that you know about?
So because of mathematics and Kepler's laws and so on and so forth, we can actually very accurately determine the locations and the times of eclipses in the past. And so we've been able to use eclipses to actually determine times of historical events. So for instance, the 2134 BC, back then the Chinese actually were able to predict fairly accurately eclipses, where there was an eclipse, and the Chinese believed that, as Pam was saying, there was a dragon that was actually eating the sun, and the emperor's symbol was the sun. And so it was very important to be able to predict the eclipse because it impacted the health of the emperor. Well, the astronomers, the royal astronomers, did not predict that eclipse, so they were put to death because they didn't predict that eclipse. And then in 585 BC, the Medes and the Lydians were actually amassing for a battle in Turkey. And it's actually one of the earliest dates that we can actually specifically know the date of a battle. And so they had been warring for 6 years, and they were amassing for battle, and the eclipse occurred, and they were so frightened they ended up signing a peace treaty. One of the most important eclipses in our history was in 1919. So Albert Einstein had proposed his general theory of relativity. And in his general theory of relativity, he predicted that gravity would warp space and would actually be able to affect the path of light, that gravity would actually affect light. So in the 1919 eclipse, they actually took pictures of the star field around the sun, and then took pictures of the star field on the other places on the Earth where the sun, where the eclipse at night, where the eclipse didn't occur. And they compared the plates, and they saw that the stars around the sun were shifted during the eclipse because the light from those stars in the background were the path of that light was affected by the sun's gravity. And it was actually, they predicted the shift was almost exactly what Einstein predicted the shift would be. And so it was the absolute proof of Einstein's general theory of relativity. And then one other thing that is kind of a fun thing is some of you may have heard of Mark Twain's book, Connecticut Yankee in King Arthur's Court. So it was actually a movie that Bing Crosby starred in, if anybody of you seen that. The story is that he got hit on the head and woke up in the 6th century in King Arthur's court. And he was battling with Merlin. Merlin was a bad guy. So he was about to be burned at the stake. And he somehow knew that this eclipse was going to occur. And he said, I'm going to eat the sun. I'm going to tell the sun to turn off. And it saved him from being burned at the stake because everybody believed that he was a wizard that had turned the sun off. So those are just some of my favorite stories about historical eclipse.
So if you want to scare really young children, you can tell them I'm going to turn off the sun on Monday. Pam, I wanted to ask, just out of curiosity, like 200 years from now, do you have a sense of what historians might make of how we're responding to this eclipse? I mean, any sense of what's going to remain in history from what we do in the next couple of weeks? Like
well, if we kind of look back at how other historians have looked at previous eclipses, it might be a good predictor of how they might look at us in the future. There's a really nice, very readable history book out there called The Great American Eclipse by David Barron, and he kind of goes back through time and kind of does a really nice, it's almost like a novelistic kind of recreation of key people who observed 19th century eclipses, and he includes people like Edison and Maria Mitchell and folks like that. And I suspect that we might have a little bit different kind of approach, which is, I think, the fact that we're going to have large groups of people really coming out for this ginormous multi-hundred-mile party may catch some attention. You know, it may actually kind of create a little bit of a resurgence in understanding nature and wanting to be back out there again. I think we saw that even in the early years of the pandemic as well, with people wanting to get back out to natural places and national parks, et cetera.
That sounds exciting. And Phil, so you mentioned the pictures of the star field and relativity. So let's talk about research now. I think for both you and Mary, what are researchers excited about with this eclipse?
Go ahead, Mary.
So one of the things, and I know that this is also very much in Phil's area, but is the space weather that we're seeing. So when we think about space weather, we will definitely be able to see effects from the sun. We can do that artificially now by actually masking the solar disk with our spacecraft and be able to really create an artificial eclipse. So that type of space weather we can study all the time. But there are certain phenomenon that are going to happen during the eclipse that are similar to what we have happening with the day-night cycle. And so one of those is that we have high energy light always coming from the sun, and our upper atmosphere protects us from it. So we're all familiar with the ultraviolet light that our ozone layer absorbs and that we also gets to the ground and we need sunscreen for. But there's much higher energy light coming from the sun. There are X-rays, there's extreme ultraviolet. Our upper atmosphere protects us, and the way it does that is those photons of light actually knock off electrons from the atoms in the upper atmosphere, so from really the gas in the upper atmosphere, creating ions. And those behave a little bit differently. They're affected by electric and magnetic fields, and we get effects with radio waves, which are a form of light, as it passes through these ions and then the neutral atoms in the atmosphere, neutral gas molecules in the atmosphere. And it's a little bit like the effect we get with visible light above a hot road in a Texas summer. Are you all familiar with what I'm talking about? Kind of that wavy appearance. And so looking through those different packets of air in the atmosphere, we actually have this distortion of radio signals. And we built a instrument here at UTD. I did not, I should say our Center for Space Sciences did, called the Coupled Ion Neutral Dynamics Investigation that flew on an Air Force satellite. And it was looking at this phenomenon with day and night. And I know we've had similar instrument packages that have flown on other spacecraft. And we actually had to create a comic book to explain this to kids, because it was just so difficult to talk about this idea of these different changing layers. And so we have this whole comic book that's available actually from the same link. If you go to the link for another comic book I'll mention in a bit, then you can download our Cindy comic books as well. It kind of explains this phenomenon. So that's related to the day-night cycle, because when we shut off that light from the sun, suddenly that source that's producing ions goes away. And then you end up with recombination, and so you get these different effects because of day and night. We're going to see a mini version of that during the eclipse, and there will be experiments happening even on our campus related to that phenomenon. So that's one way that it's actively exploring that, because these radio signals relate to our communication and navigation capabilities. We don't expect outages because of the eclipse, but we do expect to better understand this area of the atmosphere known as the ionosphere.
So, mentioned the Center for Space Sciences. One of the things, our major research efforts over there are studying the ionosphere. And we build spacecraft instrumentation and fly. In fact, right now we have 9 spacecraft in orbit around the Earth with our instruments on them. We've actually sent instruments to Mars, to Venus, to the Moon, to Halley's Comet. We flew our first satellite back in 1965, and we've been doing them ever since. We actually have satellites that are going to fly through the eclipse path, and we'll measure the change in the ionosphere when those satellites actually pass over the path. We also have instruments here on campus. As Mary mentioned, Dr. Fabiana Rodriguez has instruments that are on top of our building over where the Center for Space Science is, just across Waterview. And it's actually, we actually measure the radio signal from GPS satellites. And so imagine, so light, the speed of light changes depending on the medium. Okay, it's why when you look through water, if you drop a pencil in water and you can see it kind of looks like it's got a break in it, that's because the speed of light changes in water. It has a different speed. And the same thing happens in the ionosphere. And the amount of electrons in the ionosphere changes the speed of light. And so you can actually use a signal from the GPS satellite and measure it on the ground, and you can actually use that to determine how many electrons are between you and the satellite, in a path between you and the satellite, okay? The actual greatest error in GPS navigation is the ionosphere, and we do corrections for the ionosphere. But as scientists, we use that to study the ionosphere, and that's what Dr. Rodriguez does. And so during the eclipse, he's actually going to have these instruments on top of the Center for Space Sciences over there. And there's actually going to be a video. If you're here on campus, he's going to actually have a big screen, and he's actually real-time show the signal. And so what you'll see is, if you look at over a couple days, you'll see the density increase during the day, and then it drops off during night, and then increases during the day, and you see this diurnal cycle. But during the eclipse, what you'll see is you'll see the density going up as an increase in the atmospheric density increasing, but during the eclipse, it's going to drop off. And how it drops off and how that happens is very interesting scientifically. So that's what we're going to be studying. And I mentioned already about the corona, and before, actually the first time the scientists were actually able to study the corona was on the space, the 1972. I just went blank. Space Lab. When they were actually above the atmosphere. The problem is that I can't make an eclipse by putting a coin over the sun, because the atmosphere scatters the light. Okay, so the light's coming from everywhere. That's why we have blue skies. So I can't put a coin over it and create my own eclipse. but I can do that in space because there's no atmosphere to scatter the light. So as Mary mentioned, we have solar observatories up there that will make their own eclipses and we can study the corona. But before we had telescopes in space, we could not study the corona except for during an eclipse. So that's why eclipses were so important for studying the sun.
So my average guy question is, during the 4 minutes of totality, how might GPS and our cell phone signals be affected? Would they just continue as they are? Or
Yeah, they will. I mean, it's not, we have, I mean, they have ways to correct for the ionosphere. There are certain ionospheric effects that won't happen during the eclipse, but can happen during what we call geomagnetic storms, when the ionosphere is really disrupted by solar events, where you could actually lose communications with a GPS satellite and actually degrade the navigation. It's one of the things that it's what we call space weather, and that's why we study it, because we could actually have a big solar storm, a geomagnetic storm, and you could actually lose contact with certain GPS satellites and seriously degrade your navigation or your ability to communicate. You get things like energetic proton events that wipe out high HF frequency over the poles, and so the airplanes can't fly over it because they can't communicate. I won't go into a lot of detail here.
Okay, but that doesn't sound like a good thing, though.
No, it's not.
But you're saying that's not going to happen on April 8th?
That is not going to happen during the
Okay,
eclipse, no.
you promised that, all right. Let's go to safety before we start to take questions from the audience. So I think it's really important to think through how to view solar eclipse safely and what precautions do we need to take.
I am more than happy to take this. I feel like I've been an eclipse evangelist for the past several months. And one of the things that I want to get the message across is it is no more dangerous to be out in the sun than on any other sunny day. So there's no special space weather happening. There's nothing that's going to happen in terms of something more dangerous from the sun. You should never stare at the sun. That includes any other sunny day, don't stare at the sun. You might need a hat, you might need sunscreen, typical protection, again, for any other sunny day. You might need a bottle of water. It's April, we never know what the weather's going to be like here in Texas. But you will need to either have, eclipse glasses, and ones that actually have the right safety standard. So you should be getting eclipse glasses as you leave. You can pay attention to the standard on the back. It's talking about meeting the requirements for the particular ISO certification. So I won't read the numbers out to you here. Again, you're going to need to get a copy. We bought our glasses from a reputable vendor. So we actually bought them directly from the manufacturer, so you know they're safe. So you do have to be a little bit careful about knockoff glasses. So I recommend people go to our website, and from that you can see the link to the American Astronomical Society's list of safe eclipse glasses if you want to get more for family and friends. So during the phases that we see here, all the yellowish images where we're either not in eclipse or you're starting to go into that partial eclipse and experiencing the partial eclipse, you either need something like this, or an approved solar filter to look directly at the sun, or you can use a wide variety of indirect viewing methods. You can look under trees. I don't know if anybody did this in October. You can use a colander to project images on the ground. You can do exactly what Pam is showing and make sure that you're actually looking down at the ground. Don't do like this, right? I've seen adults try that. Don't do it. Right, you can punch a hole in an index card. Anything that's basically creating a pinhole projector of that shadow on the ground, and you will get an image of the sun. And it is absolutely amazing to do, even if you have eclipse glasses. It's a lot of fun. We had children who were just going crazy doing it in the October event. But what's going to be different from October, for any of you who saw that, is that central image there. So when we get to totality, when it's completely dark, the sun is completely covered, you don't want these anymore. You don't want to be looking down at shadows anymore. You want to be looking up at the sky. because it will be completely safe as long as the moon completely covers the sun. And that's where the timing really matters. So we see, for example, 4 minutes of totality. That will be true for downtown Dallas. It won't, again, be true for this campus. And it certainly won't be true for Denton, right? They get 0 minutes of totality. They will always, in Denton, need to make sure that they have safe protection from the sun or are using those indirect viewing methods. And for those of you who have children, grandchildren, are teachers, any of that, we have safety comic books for free on our website in color and in black and white that can be used for coloring. It's in English and in Spanish, so I encourage you to go to our website and download that as well.
So Mary, it sounds like you have to really time it so that you're using your glasses as it's partially obscured, but then for the 3 to 4 minutes of totality, you can actually look at it. Will you know when not to look at it?
I'm going to set a timer on my cell phone. Because for one thing, I'll be announcing to the crowd as well. But the other thing is, I don't want to be staring at my phone and looking at the time. I'm going to be paying attention to the eclipse. And so to do that, I want something else to remind me about when it's safe to take my glasses off and when I need to put them back on. And again, some places will be a minute, some places will be 2 minutes. It's really important to check that timeanddate.com or get one of the Eclipse apps, such as the one that's recommended by the American Astronomical Society, to make sure you have that timing correct at your location.
Yeah, I
Phil,
don't think.
before you jump in, let's make sure to get the reader audience questions from the audience. Thanks. Go ahead.
I don't think you actually mentioned it, but on date and time, there's a map. You can actually blow up the map and you can click on the spot where you are watching it, and it'll give you the exact time to the second of the eclipse.
Yes, thank you for mentioning that, Phil. That's really important.
I think part of what we also want to know is, like, why is it dangerous to stare at the sun? What is the physical effect?
You don't want to burn your retina. We all know sunburns are bad on our skin. Our retina is so much worse. It doesn't heal the way skin does. And we also have really the magnification due to the lens in our eye. We don't want any of that on the retina. So my understanding is you can get eye damage within about 5 seconds. I have had even undergraduates tell me, I stare at the sun all the time and I'm fine. Do not do it. It's cumulative eye damage. So make sure, don't stare at the sun ever, not just on eclipse day.
Also, your camera. You can burn out your camera. So if you're going to take pictures before the eclipse, before the full eclipse, if you're going to take pictures of partial eclipse, make sure you have a solar filter on your camera.
And a solar filter rated for that equipment. So there are different filters that you would get for, and a different certification for a camera, for binoculars, for a telescope. You want to make sure that you're using something that is designed for that equipment, particularly if it has an optical viewfinder.
And what about cell phone photos?
So cell phone, honestly, without an optical viewfinder, I might use this, but there are filters that are designed specifically for cell phones.
And I know that and again, a plug for us, dallasnews.com/eclipse. We have a story about how to take photos of an eclipse. Okay. All right, just to follow up on the eclipse glasses, let's be more specific. How do you know if your eclipse glasses are any good?
Okay, so there are a couple things you can do. One is to check that American Astronomical Society website, because they have listed the manufacturers that have the actual, meet the certification standards. They have the manufacturers from the US, they have manufacturers from China, they also have approved vendors on that site, and these are all ones that have been checked by the American Astronomical Society. The other thing you can do is actually check your glasses. Now, the bad thing is this will only tell you about visible light. It won't tell you about its ability to block out anything but visible light. But you should not be able, really, to see much at all through these except for the sun. If you're really close to a very bright light, you may be able to see that through the eclipse glasses, but you certainly shouldn't see anything else. So if you can see, like if you hold up your cell phone light and you can see it and it looks really bright through here, those are not good eclipse glasses. So be very careful. There are knockoffs. In 2017, it was truly unfortunate. We had report after report of children being kept inside by principals and teachers being kept inside by principals because they had bought counterfeit eclipse glasses. And that's one of the reasons why we're emphasizing that you don't even have to have these. There are a variety of indirect methods you can use, that the sun is not more dangerous on eclipse day, and we have the comic book to help children drive the safety conversations. But if you are worried about your glasses, you can check them those two ways. Again, American Astronomical Society, we have the link on our website for their safe eclipse glasses. And then there's also making sure that it's not showing light through it.
Question possibly for Pam. Do we know when was the first known eclipse or known total eclipse in history? Or like when was it first recorded?
I actually think probably what Phil was talking about is the earliest historical known one. We don't have any other way of finding out. I mean, that's one of the weird things about history of astronomy, of course, is that we can only go by whatever kind of, material evidence we have left. It doesn't tell us when somebody really did something first. So we tend not to think about that kind of timeline that way in history of astronomy so much anymore.
But like for instance in China, well, they have a history. They know when the emperor, there was a story about this emperor. They know who the emperor was. They know when their eclipse actually passed over the emperor's palace, so they can actually date the time because of that.
Do we know historically when it was first understood in the way that scientists understand it today? Like the known science?
The short answer is no.
Okay.
No, we don't know the first time when that occurred, and it probably did not occur just once. There were probably many firsts in many different cultures where that finally kind of dawned on folks. We know that the ancient Greeks did for sure understand the kind of three-body problem that was going on. Yeah, but other than that.
Interesting question about people in space. How will the astronauts on the space station view solar eclipses, and are they affected in a similar way, or is it just not kind of part of their experience?
The chances of them actually viewing a solar eclipse are very, very small. The space station is traveling at 17,000 miles an hour around the Earth. And the chances of them actually hitting a spot that is, 50 miles across in that time is probably extremely slim.
But they might see the shadow falling on the Earth. So there
they will
is a
see the
camera. It's the EPIC camera. It's a NASA camera on a NOAA satellite. It takes time-lapse images of the Earth. It saw the 2017 eclipse. It saw the annular eclipse in October. It will see this one as well. And if you want to know what that looks like, NASA's eyes.nasa.gov and their solar system part of that interactive, it's a free interactive, runs in a web browser. They actually have one for the upcoming eclipse, and they have actually simulated also what that's going to look like on the NASA Eclipse website.
I realized as I said that they will actually probably cross the path because they're going around the Earth and they're going to cross the path. But again, very quickly. It's 50 miles wide and they're going 17,000 miles an hour. So they're going to go across it very quickly.
Like 2 seconds of totality, perhaps. Another space question: where will Venus appear during the eclipse? Smiley face.
If I remember correctly, Venus is going to be in the sky close to the sun, but I'll have to double check that.
It's early afternoon.
Some airlines are planning eclipse flights during the eclipse. Why are they doing that? What can be seen from airplane windows? You can't look up at the sun. And just so you know, we have Xandra Scores and Smiley Pool on one of those Eclipse flights. So they'll be sending feeds from a plane. But so what's the purpose of an Eclipse flight?
I can tell you, to me, it's an extreme eclipse chaser. They want to be in totality longer than they could have it on the ground. You think of any other reasons?
So I mean, they're literally, the plane will be kind of following the path, and so you may actually be in darkness for more than.
That's my understanding, and so they'll see twilight even better probably than we will on the ground, but the idea is to stay in the eclipse shadow longer.
But remember, the eclipse is going across the ground at 1,600 miles per hour. So the plane is going 600 miles an hour. So it will not be following it. It may stay in it longer. I personally would not get on an airplane to do it. I want to stand on the ground and watch it.
Okay, so we need to change our assignment on that then? Okay. How does the rotation of the Earth affect the view of the eclipse? And it's too cold in the auditorium.
That's just the way it feels when the temperature drops during an eclipse.
We're getting ready for it, right? So, but how does the rotation of Earth affect the view?
The rotation of the Earth is definitely affecting where the shadow is falling on planet Earth. So we are, in effect, rotating under the lunar shadow.
Not to get too technical, but there's something called the serocycle. So every 19 1/3 years, something like that exactly, it actually occurs on the same place on a sphere. Okay, so the sun, the moon come into the same orientation with each other, but it's also a third of a day. So every 19 years, it shifts by a third of the day, so 120 degrees in longitude, and then it comes back around. So it's something called the serocycle.
I think two related questions. Were the ancient people able to predict eclipses, and if so, how did they do that?
That's a big question, and it really depends on who the ancient peoples were. There's some good examples in Mesopotamia and Babylonia where the predictions weren't made in the way that we make them today, right? They actually just kept track for a long, long time and began to detect patterns in that visual data. And that required figuring out a way to literally write stuff down, put it in a way that would then also be understood by the next generation for at least 400 or 500 years until they began to see the patterns, and then they used that to predict eclipses. But that took a long and kind of, multi-generational effort.
But imagine the power that ancient astronomers had.
Yeah.
When they could predict this. So I do talk about this with my own astronomy students, and I am not a historian of science as Pam is, but it's really powerful, the idea of what astronomers could predict that the general populace didn't know. So being astronomer priest back in the day,
Not a bad gig.
yeah.
And so in more modern times, Edmund Halley, who some of you may know as kind of Isaac Newton's sidekick, the guy who kind of got the Principia into print and whatnot, he during the 18th century was really one of the first ones to use scientific prediction, because obviously he also had the comet, which had not yet returned, but he was already making those kinds of predictions. He realized that that would kind of deflate superstitious beliefs, right? That if you would no longer have people fearing these things because you could tell them when they were coming, and you could also explain what natural things were causing them.
Then a related question about current time. How can astronomers accurately predict total eclipses to the point where they're saying the next one's 2317, right? So how do they do that?
Well, I mean, it's the same way we predict orbits and send spacecraft to Mars. I mean, it's the physics, the mathematical equations, and Kepler's laws, and 3-body and 4-body physics. And you can actually very, very accurately predict the orbits of the planets, the moons, the asteroids. It's all just mathematical physics. I mean, it was Kepler that actually first developed his three laws, orbital laws, and it was actually he was actually hired to try to explain the orbit of Mars, and it was the beginning of the Copernican revolution and the realization that the sun was actually the center of the solar system.
And I could add more to that you all have the power now to see those predictions animated. The eyes.nasa.gov, that website I mentioned before, it actually has the full Jet Propulsion Laboratory ephemeris. So it's keeping track of where all of the objects that are being tracked by NASA are in the sky. So that is all of the naturally occurring objects, are the artificial objects, so all the spacecraft. And you can interact with this, and it's really phenomenal. You can also change the time that you're looking. So it is in effect like a free planetarium program, but it allows you to actually, say, zoom through the solar system. So there's eyes on the solar system, there's eyes on Earth, and then there's also eyes on exoplanets, which is a whole different topic, but one of my favorite things.
I mean, imagine how do you send a spacecraft to an asteroid that's 100 meters across? I mean, it's amazing, but it's just physics.
The same person asks, and will there be cupcakes? I'm not sure I understand that, but I'm just reading the questions.
Oh my goodness, in Nebraska there were so many baked goods. I'm just saying, you could go into any bakery and they would literally have cupcakes that were actually decorated in all the different phases that you were going to see. And then of course the big one with totality. Also I had glitter. I'm saying glitter plays a role. So yeah, and I had a student, not just last semester, I have an assignment, I have them kind of combine some kind of visualization with their astronomy knowledge. And one of them designed this most amazing eclipse cake with fondant, and it was just like, yeah. So this idea that astronomy and eclipses is all science-y, it can also be about baked goods.
Yes, and I will have to say, for any representatives of UTDallas student groups in the audience, we have booth space available. If you would like to host a booth and have baked goods, I know many hungry people who might like to buy them.
So as we wrap up, I just want to do one final lightning round. So if you have one number one tip for first-time Eclipse viewers, what might that be?
One is hard.
Two.
Okay, so one thing is traffic will be very, very bad. If you can observe the eclipse where you are going to be, your school, your workplace, your home, your nearby park, as long as you're in that path of totality and have a view of the sun in the sky, as Phil was talking about earlier, that's a great place to see the eclipse.
And your ability to drive away afterwards will be really hindered. I've been
Oh,
told
it will
that
be.
Traffic.
So don't expect to leave work or school or home or the public park very quickly, particularly if you're in a car.
I think my tip would be to remember that the eclipse is not just a special effect, it's a process. It takes 3+ hours to occur, so if you happen to be somebody who is shepherding little ones, your kids, or in my case, my grandkids, through their very first eclipse, I would do some practice sessions with them, actually practice glasses on, get them behind the braids and the earrings and all that kind of stuff, glasses off, glasses back on. And also give them some activities before and after to do. There's a lot of fun stuff you can do, paint pictures, write a poem, develop your own cute little song, sing it together as a family. You can make Eclipse friendship bracelets. You can carve even the fillings of Oreo cookies into the shapes of the crescents that you're gonna see. Very simple, fun things like that. But the fact of the matter is, regardless of their age, you can get them involved, and this is also true for teenagers. have them check out the citizen science activities that are also listed on our website. You can actually, as a family, join in and do real-world science that's actually ongoing. And most of those projects include arts, humanities, and the sciences all together. So it can be really fun for people of all, for whole families of all ages.
And of course, we have that comic book too, just to plug again.
I would just say, just plan and enjoy. Just sit down and enjoy an experience that you will likely not experience the rest of your life, that you haven't experienced yet, and you probably will not experience in your life. And listen to The Dark Side of the Moon by Pink Floyd.
All right, so some programming notes as we wrap up. Great thanks to UTDallas and the Dallas Morning News for hosting and organizing this wonderful panel discussion. You can find our coverage at dallasnews.com/eclipse, and make sure to come to our website, dallasnews.com, on Monday, April 8th for full coverage. And you make sure to get your Eclipse glasses on the way out. Let's give a hand to Mary, Pam, and Phil. Thanks, folks.